All right, guys, this is our final lesson of our simplifying square roots unit. We are looking at simplifying variable powers in the radicand, okay? So when we work with variable powers, remember variables are just those letters that show up in math sometimes. We're used to seeing x, y, z, stuff like that. And we can actually take the square root or just take various radical values of those variables depending on what they look like. So for instance, with even powers, the square root of x to the fourth, the square root of x to the 16th, the square root of x to the 10th, what we kind of want to look at here is what times itself can give me x to the fourth. Now, if we remember my variable rules, when we have a power to a power, we want to look at multiplying. So if I have x squared to the second power, remember if I have a power to a power, I'm going to end up multiplying my exponents. So 2 times 2 would give me 4. Okay. Same thing with x to the 16th. I need something multiplied by 2 in order to give me x to the 16th. Well, really what we can do is we can take 16 divided by 2, and that would give me x to the 8th. Okay, so what we're looking at here, same thing like when we started the square roots and radicals earlier in this year. We want to think of what times itself will give me my final result of x to the 16th. So for the third one, I have x to the 10th. So I need to say, okay, well, what times itself will give me x to the 10th? In this case, I would need something times 2 to give me 10, and that would be 5. So my rule with even powers, okay, my rule with even powers would be half the exponent. Okay, so if I'm taking even powers, I'm taking the square root of even powers with variables, I can just take half of what it is, right? Let's look at some of our answers. The square root of x to the 10th, half of 10 is 5. Square root of x to the 16th, well, half of 16 is 8. X to the fourth, half of 4 is 2, right? That's if we're taking the square root of even powers. Okay, that's pretty easy, right? Well, looking at odd powers, it gets to be a little different. What we need to do with odd powers is we almost want to treat this like one of those numbers that are usually under a radical that aren't a perfect square. Remember, if we have a number that's under a radical that is not a perfect square, okay, we need to find a perfect square that goes into it. Well, in this case, we're not dealing with numbers here, so we need to almost just look at, well, how can I make my exponent even? And in this case, I need to split it apart into one of them being x to the fourth, an even one, and the other being just x, right, which is still odd. Well, I know how to take the square root of this one thanks to the stuff up here. Okay, the square root of x to the fourth would be just x squared. And you can't actually simplify the square root of x any further. That's as simple as it'll get. So basically what you're trying to do here is, if we think of our number system and the way numbers work in math is, we have 0, 1, which is odd, 2, which is even, 3, which is odd, 4, which is even, and so on and so forth. So really we just need to take something out, which is usually just 1, to make this number the exponent and even. So for instance, if I have the square root of x to the 11th, I would want x to the 10th, 11 minus 1, and then I would have my other x with the 1 here remaining in the radical over here. Well, of course, we can take the square root of x to the 10th. We already did up here, but it's even, so we can just half it. So it'd be x to the 5th times the square root of x. Okay, so for odd ones, what we want to do is we want to take one out. So if I have the square root of x to the 7th, I would say, okay, I would have the square root of x to the 6th and the square root of x. We know how to do this. It's even, so we can just take half of it, which would be x cubed times the square root of x. So with odd powers, we want to break off one factor, right? If I take 1 away from every odd number that you can think of, it's going to be an even number. So if we think of any odd number, 27, let's take 1 away from it, 26. That's an even number, right? Okay. So we want to break off one factor and then square root the even power. Now that remaining factor that we choose, just the 1, we can't really do anything with that. Okay, we can't, because it's still odd. So these answers right here would be about as simplified as we can get it. So this part right here is really all we're doing with most of our 4.0 content, okay, is we're looking at even and odd powers and how we can take the square roots of them, okay? So this is a little help station on how your calculator can help you. This stuff right here, if you guys want to pause it and take a look at it, it'll help you when it comes to entering perfect squares for x, looking for whole numbers in the y column. This can help you with simplifying radicals, okay? So for number 1 here, I have the square root of x to the 8th, y to the 6th, and what I want to do first is obviously check if they're both even, and of course they are, so I can just take the half of each of them. So half of 8 would be 4, x to the 4th, half of 6 would be 3, y cubed, or y to the 3rd, okay? So those ones are pretty easy, right? We just had variables. They were both even exponents, so we can just take the half of both of them. For number 2, I have the square root of 16x squared. Well, 16 is a perfect square, so we know we're going to be able to take the square root of that. And x squared, my exponent, is even, so I can just take half of that. So I would just have 4x. And this x is assumed to be raised to the first power because, of course, half of 2 is 1. Okay? So for number 3, I have the square root of 242y to the 5th. Here it gets a little tricky. 242 is not a perfect square, okay? And y to the 5th is an odd power. So what we want to do is we want to break apart 242, like the very first lesson that we learned how to do. Okay, we want to take out a perfect square factor. 121 is a perfect square that goes into 242. So I'm breaking that apart into 121 times root 2. Okay, and then y to the 5th, just like we learned on the last page here, on the last slide, okay? If it's an odd power, we need to break off one factor and then square root the even power. So what we're doing here is we are breaking off one factor, square root of y, and what's remaining is an even one, square root of y to the 4th. Okay, so I can simplify the square root of 121, and I can simplify the square root of y to the 4th. Okay, and notice how I'm moving this over here. Remember, most of my stuff that I can take the square root of, or in other words, evaluate my square roots, okay, a perfect square, you can do that, and variables with even exponents, you can do that. We move to the front of the solution. Okay, so the square root of 121 is 11. Square root of y to the 4th would be y to the 2nd. And these ones I can combine to put under one radical because this would be its truly simplified form. Okay, so here we're just picking out the stuff that we can actually simplify. In my class, I show students to underline the things that you can simplify. We know we can simplify the square root of 121. It's a perfect square. And we know we can evaluate the square root of y to the 4th because it has an even exponent. Okay, so I would have underlined both of those, and anything you can evaluate or move to the front, go ahead and do that. Okay. For number 4, I have the square root of 125 x to the 4th, y to the 7th. Again, here we kind of have a mixture of both things going on. Okay, so the square root of 125 is not a perfect square. Okay, x to the 4th we're going to be able to work with because it's an even exponent, and y to the 7th is odd, so we're going to have to do some work with that part too. So what I'm going to start with is I'm going to start by taking out or breaking apart 125. Now, this might look a little funky compared to the last one, especially because here we did them all separate. The only thing we're doing different with number 4 here, you guys, is we are combining the stuff that we can evaluate and simplify under one radical and the stuff we can't under the other. So we're just going to take less steps. Like this one, we're breaking it all apart, okay? But this one, we're just taking less steps. We're putting everything we can evaluate and simplify under one radical and everything we can't under the other. So this 25 and 5 is coming from simplifying 125. Perfect square that goes into 125 is 25. X to the 4th, like I said at the beginning, okay, we can evaluate that, so it's just going to hang out in the valuation one, okay? And y to the 7th, it's odd. We have to take out one factor, and then the even factor we know we can work with in the left one here, okay? So when I evaluate this one, I would get 25. Square root of 25 is 5. Square root of x to the 4th is x squared. And the square root of y to the 6th is y cubed. Of course, we know we can do that. We have even exponents for the variables, and 25 is a perfect square. We know we can't do anything with this remaining one, so it's going to stay exactly the way it is. Okay? Number 5 is going to be kind of similar. The only difference with number 5 is that we have a coefficient out front. So I have 2z times the square root of 300z cubed. Of course, we know we're going to have to do some work with both things under this radical because 300 is not a perfect square, but there is a perfect square that goes into it. And z to the 3rd, of course, is to an odd power, so we're going to have to work with that too. Now, this 2z is going to have to stay out front. Again, everything we can evaluate, we're going to put under the left radical, 100z squared, and everything we can't, we're going to put under the right, the square root of 3z. Okay, so I would get 2z times square root of 100 is 10. And the square root of z squared is just z times the square root of 3z. Again, we know we can't do anything with this one. So this one's really not going to change from that first step we take all the way to the end. Now this I can do. 2z times 10z is going to give me 20z squared times the square root of 3z. So notice that square root of 3z doesn't change from that first step all the way to the end. And here we're just combining and multiplying. Right? For number 6, I have 5y cubed times the square root of 432xy to the 7th. Here we kind of have some issues. Y to the 7th raised to an odd power, x to the 1st raised to an odd power, and 432 we need to find if there's a perfect square that goes into it. So I have 5y cubed out front. Again, it's just going to come along for the ride until I can evaluate everything else. 144 is a perfect square that goes into 432. It goes into 432 3 times. That's where the 3 and the 144 are coming from. Y to the 7th I can do some work with because there is an odd factor. So x we know, sorry, before we get into y, let's look at x first. Sorry, guys. The x we know we can't do anything with, right? Because it's to an odd power. We can't take one factor out because there really only is one, okay? So we know the x is going to get tossed into the radical that we can't do anything with, okay, which is the right one here. That's why it's over here and there's no x's in the left one, okay? But y to the 6th, there should be a y over here, guys. It should be 5y cubed times the square root of 144 y to the 6th, right? I'm taking my one factor out and putting the even one on the left side times the square root of 3x. There should be a y here, okay? So when I do this, I would get 5y cubed times the square root of 144 is 12. And the square root of y to the 6 is y cubed times 3, the square root of 3x. Again, there should be a y right here, guys, okay? So I would get 60y to the 6 times the square root of 3xy. There should be that y there. Okay, and that is it for today. Let us know if you guys have any questions on this. This stuff can get a little tricky, but I think once you guys start to notice the pattern of taking out your odd variable and leaving the even factor in the evaluation square root, it's a lot easier to identify what we're doing here. Okay, and then but from then it's just multiplying. We know how to multiply coefficients and variables at this point in the game. Okay, again, there should be a y under the square root here. There's not. I'm going to go back and add that right now. Okay, let us know if you guys have any questions.